Yesterday we had congruence transformations. Today we're going to have similarity transformations because the figures will not be congruent. It's going to be a composition. So if we look over here, it says you can use you can use compositions of a rigid, which is an isometry, and a dilation, and then you end up with similarity. Similarity means same shape, different size. So that means the angles, corresponding angles are congruent, but the lengths will be different. So what you're going to do today is you're going to do a reflection and dilation, rotation and dilation, translation and dilation, that sort of thing.
Okay, I have a really quick question.
And the way I'm going to do this is different than the way the book did it. So if you go online, you can see the exact same thing because the person that made these notes just copied the book, cut and pasted, and you can see how the book did it. But I'm going to do it where I think it's easier to see. Easier for me to see anyway, yes.
Okay, for a dilation, what can you just tell me, like, really quick, the way to tell if it's an enlargement or a...
If the pre-image is small and the image is big, it enlarged. If the pre-image is big and the image is small, it's a reduction.
Okay.
All right. Shh. These are online. Okay, so let's do this one. All right, so they have asked us to take DEF and to do this. What is this telling me to do first? No.
Reflect over the Y.
We always start on the right, we move to the left. We reflect over Y, then we're going to dilate. So before we do anything, do you agree that we probably should graph our points? This is D, which is 2, 0. This is E, which is 1, 4. And then we've got F, which is 2, 4, 2. Do you want to make that bigger? Oh my goodness. I don't know. It's spazzing out. I agree.
Sarah, go back to the next slide. This slide. I say we just call it A for notes. Yeah, maybe. Early dismissal. Oh, it's done.
No, it's not done. Look at all the way to the bottom.
Now you got a
Barcode.
Hey, Trevor, try to scan it.
With what?
Your phone.
With the have that.
Don't have
It's okay. It's okay.
All right. Shh. What did I do to fix it? I just opened a new one. Because I can't work the smartboard when it does that. All right, I need a graph paper. All right, the problem is in my graph paper box. So no, I cannot make it bigger.
Yes.
Okay?
No, it's 2.3.
Wow, that is a weird graph.
All right. So we're going to be working on this graph. So here we go. Shh, quiet. All right, something's not. I'm trying to. This is not going well. Yeah, I'm actually recording right now. Yeah, so let me see if I can do it from here.
If you're recording this, remember to do your homework. So this won't happen. Stan is always watching children.
All right. You ready? We've got the axes. All right. So we're going to graph. Quiet. 2, 0, which is here, and that is my D. We are going to graph 1, 4, which is up here, which is E. We are going to graph 4, 2, which is F. Okay, so we've got a triangle. Now we're going to, We're going to reflect over the y-axis first. All right. So we are going to take another pen. And this is 2 units over. We're going to come 2 units over, which is D prime. F is 4 units over, so we're going to come 4 units over. E is 1 unit over. So that's going to be E prime. So what we have now is we have this triangle, a reflection. Now what does it tell us to do? Dilate. So I'm going to take my D, and I'm going to multiply 3/2 times 2 and 3/2 times 0. And I'm going to do that because that's what 1.5 is. So D prime is going to be 3, 0.
I don't understand this part.
E prime, I take each one of these coordinates.
Thank you.
We're going to take 3/2 and we're going to multiply by 1. We're going to take 3/2, we're going to multiply it by 4. So this is going to be 3/2 and 6. Then we're going to do our F prime. And our F prime, we're going to take 3/2 times 4 and then 3/2 times 2. So that's going to be 6, 3. So now what we're going to do is we're going to come over here and we are going to graph 3, 0. So we're going to do 1, 2, 3, 0. Something's wrong. Did I have any negatives there? Oh, I'm supposed to take my primes. Did I use my primes ordered pairs? What did I use?
Well, now you just original.
So this is negative 2, 0. So I'm multiplying this by negative 2, 0. So this is going to be negative 3, 0. Sorry about that. On E prime, that's going to be negative 1. And then we're going to multiply this by positive 4. So we're going to end up with negative 3/2, 6. Then we're going to take F prime, which is negative 4, and we went up 2. And when we multiply by that, we're going to end up with negative 6. So we're going to go over negative 3, 0. We're going to go up 1 over negative 1.5, 2, 3, 4, 5, 6. And then we're going to do negative 6. Up 3. That is the dilation of the figure after we're finished. I just plotted those points.
So you did a glide and now you
I did not glide, I reflected, and then I blew it up.
Wait, so that's all you do?
That's all you do.
Dilation?
Yep.
Wait, it's easy. I can
Pardon? All right. So this is a transformation of a dilation and a congruence transformation.
How do you get 3/2 on the graph?
I went over 1.5 up 6. Right. All right, there should be no talking.
Yeah, guys.
Trevor?
Yes.
I don't need your help. Yes.
I know you just said this, but how did you get 3/2 on the graph? You went over 1/2 and 1/2.
Uh-huh.
How many? Oh, you went up 3 over. You went up 6. No,
Yeah.
3 over 2. No, 3 over 2.
I can multiply by a fraction better than I can multiply by a decimal.
For multiplying by decimal. Yeah.
Then you do that. All right, I need to finish the lesson. This is online. You can go back and look at it and you can finish your notes. Now, we want to match RST onto PZY. All right? Now, the way the book did it, I found very confusing. So, do you see they're different sizes? The first thing I'm going to do is get them the same size. Then I can do the isometry a lot easier. They went ahead and did the isometry and then blew it up. But I think that's harder to do. So if I want to figure out what the dilation was, I have to take image over pre-image to get the scale factor, correct? All right, so if this is the image, or pre-image, this is the image. So I'm going to figure out that RS is here. How long is RS? 2. RS corresponds to PY. PY is 1, 2, 3, 4. So my scale factor is going to be 4 over 2 or 2 because we do image over pre-image. Then I take my ordered pairs, which is 1, 1, which is R, and that's going to become my P prime, or I'm going to call it R prime. R prime under a dilation of 2 is going to be 1 times 2, and 1 times 2, or the ordered pair 2, 2. Then I'm going to take my t. What are the ordered pairs for t?
I don't know.
3, 1. And I'm going to take it through the same dilation. So it's going to be 3 times 2, 1 times 2, or 6, 2. Then I'm going to do RS. S is 1, 3. And I'm going to take it through the dilation. So that's going to be 1 times 2 and 3 times 2, or 2, 6. So now I'm going to plot. I've got 2, 2, correct? And then I've got 6, 1, 2, 3, 4, 5, 6-ish. And then I've got 2, 6. 2, 1, 1, 2, 3, 4, 5, 6-ish. So this is my new figure. So the question is, all right, RST is clockwise, PYZ is clockwise. So it's going to be a rotation. So we know that R corresponds to P. So if I were to take a segment through here, it's going to be a rotation. That is not what we do. It's a rotation of 180 about the origin. But what did I do before that? Dilation of 2, and that is of triangle RST. Now listen, if I reflect it over at y equals negative x, then that means that this S prime falls on Z. Z is last, S is in the middle. Those points don't correspond. So yes, no. Yes, if they had put the letters in a different order, we could have done that.